Today's video is about the zero product property to solve quadratics. And so remember, a quadratic is ax squared plus bx plus c. Some kind of x squared term makes it quadratic. And we are finding the x-intercepts if we have a graph. So you can see how to find them, or you can take the square root. Just a quick review. So the x-intercepts, not the y-intercepts, the x-intercepts are the solutions there. So 0 and 4. That's what we're going to be finding. Not so much with the square root property. So here would be -1 and +2. This is square root property. We'll talk about that at a different time. Skip over those for now. We want to focus on when we have to factor to solve. So there's a couple different things here in your notes. Take a look at. So it says compare and contrast the following two questions. So if you notice, those things are both the same, and we just spent a lot of time factoring, and we could factor that into x plus 4 and x plus 2, and then we'd be done. Over here, what the difference is, we have an equal sign. So we factor this into x plus 4, x plus 2, we can actually solve. So that is a big difference. The equal sign makes it a solving question. And this would just be simplify or multiply. Okay, so let's stop and do these examples. These are already all similar to that second one. And so one thing that you need to know about what's called the zero product property is that when you multiply something by 0, you get 0. No matter what, you multiply by 0, you get 0. So what I need to do is to find out what makes these expressions equal to 0. Sorry, I'm having a little crazy time with my mouse. There we go. Okay. So what I need to know is what makes this 0, what makes this 0. So all I have to do is set them equal to 0. Because if either one of these is 0, the whole thing is 0. That's the zero product property. Product means multiply. So -4, and I know that 0 times anything is 0. Whenever you have a term out here without a plus or minus with an x, the solution to that is going to be 0, because you put 0 in, that makes it true. So here is the key right now. You're writing down the fact that you set that factor equal to 0, because they're not always going to be ones where you just look at them and see. Some of you are already seeing the shortcut, right? 4 minus 4 is 0. -4 plus 4 is 0. That's why that's true. So like the shortcut is 5 minus 5 is 0. So that's one of the solutions. -1 plus 1 is 0. But that comes from the fact that you're setting this equal to 0 and solving it. Okay, and then over here we get to ones that, a little trickier. So it's already factored. I just need to set my two factors equal to 0 and solve a little two-step equation. So add 6, add 6. If 2x equals 6, can't fit it on there. If 2x equals 6, then x equals 3. And over here, add 9. If 3x equals 9, x equals 3. So that's the same solution. Okay, so looking at these already factored ones, we can just look at them and get the answer pretty much, right? So, bam, that's one of those special cases. X equals 0. And for this, x equals -9. Bam, x equals 0. X equals 6. Whatever makes that inside 0. Bam, x equals -11. You might want to be careful here. Let's use our long rule there. So 7x equals 14, divided by 7, x equals 2. So that, again, two solutions. And then both of these, you're going to need to set them equal to 0. You might start to see a shortcut, but just so you know where the shortcut comes from, it's solving. So we're just solving this little equation. And you can leave it like that, or you could change it to 2.5, 3.5, whatever you want to do there. I would just leave it as a fraction. It's going to put these answers in for you. Okay, so at the bottom of the page, there's a summary of all of the steps, and it's blank on your notes page, so make sure you fill this in. The first step, set the equation equal to 0. All the problems we just did, the equation was equal to 0. Second step, factor, which is what you've been working on a lot. Then you set each factor equal to 0. Sometimes you will just do that mentally. Sometimes you'll need to write it out and then solve what you have. Okay, so I'm going to use my regular solving rules. So I see two terms here. I'm check, set equal to 0. It's already set equal to 0. I can take out an m and factor this way. I know that the only way I can factor is a difference of squares or GCF with two terms. So once I have it factored, it's really pretty easy. Okay, that's the key. Now my solutions are 0 and -5. So we set each factor equals 0, but this one we're doing mentally. Second one, 3 terms. I know I'm going to solve by guess and check. So I pick my numbers. Let's try, I got 4 and 3. I got 6 and 2. 6 and 2 can give me 8. Double check, 6x plus 2x, 8x, 6 times 2 is 12, good. Now we have factored, we're going to set it equal to 0. So x plus 6 equals 0, x plus 2 equals 0. Again, I think you can solve that mentally. Okay, next one. Set equation equals 0. It already is. Factor, 2 terms, difference of perfect squares. V minus 2, V plus 2. Solution is 2 and -2. Sometimes you'll see it like this, plus or minus 2, because there's 2 solutions. Pause, go ahead and try these. And I'm going to work them out. Okay, so unpause, hopefully, and checking your work there. Okay, so now we are to the ones where we have to actually start at that first step. So if you notice here, it says set equation equals 0. It is not yet equal to 0. So I'm going to move this 3y squared over. I'm not getting rid of anything. I'm just rearranging things the way I want them. So now everything's set equal to 0. I can worry about factoring. So I have 3y and y. I'm going to go with 7 and 2. If that works. 7 times 3 is 21. 2 times 1 is 2. Yep, that works. Both positive. So get everything on one side. Don't start factoring without that. All right, now I can set each of these two factors equal to 0. I know the second one is y equals -7. First one I have to subtract 2. and I get 3y equals negative 2, y equals negative 2/3. You might be noticing opposite sign, divide. Okay, so this one not equal to 0, so I'm going to bring it over. And it's getting crazy on me here. So 9n squared minus 49 equals 0. Two terms, two perfect squares. Difference of squares, DOS. So if you notice, the difference of squares have the same root, different sign, same solution. 3n minus 7 equals 0. I have to do it up here. Add 7, divide by 3. So that's going to be 7/3, which I know that this one is going to be the opposite of that. Okay, it says you try, you can pause it. But again, these are both ones you need to set x equal to 0 first. One thing you might also see on 11 is you could divide everything by 2. That's basically taking out a GCF, and it's gone when you're solving. So now this factors c minus 5, c minus 4. So the solutions are 5 and 4. 5 minus 5 is 0, 4 minus 4 is 0. Difference of two squares. 8 and negative 8, or if you like, plus or minus 8. So it's summarizing the steps, right? Set equation equal to 0, factor, set factors equal to 0, solve both equations. So pause the video. I am going to, I'll work these out, you work these out, and then you can play the video to check them. Thing to note, just note the signs there. After I factor, remember the signs are going to be opposite because you're plugging those in. Those are all pretty easy ones to plug in. Again, pause it. These are a little harder. Pause it right now so you can work them out. Again, noticing here on this difference of squares, you have the same solution. This is going to be a fun one to factor. Five and 3. Took some guessing and checking there. You got to see that process. It does take some time to check. So we have -5, -24. So we have 8b minus 5 equals 0. So b would be positive 5/8 because we're adding 5 dividing by 8 and 3. That was a good factoring one, whoever put that on there. I'll move everything to the left and do it at the same time. And rewrite down here, I have some more space. So 7m squared plus 29m plus 24 equals 0. So I'm going to go 8 and 3. 8. 8 plus 21. Oof. So m equals -3 for that one. And then if you can figure out the shortcuts now, that's fine. But if not, 7m plus 8 equals 0. -8/7. That's all. That's a lot.